Okay, everyone, thank you for coming along today. I appreciate you taking the time. So we're going to talk about data science products with R and Docker. Because there's going to be different demos throughout this, it doesn't really make sense to kind of have the full screen up. So this will be about the size that we're working with today. So we're going to be looking at how people who use R can get things into production. Hi, I'm Steph. As Mark said, I run a consultancy here in Cardiff. I get to spend my days when I'm at home with my 2 doggos and, of course, my husband, who's at the bottom of the pecking order in terms of the dogs. So, AI MVP used to be a data platform MVP, and I'm mostly concerned with how can we get value quickly. So we're going to be talking about getting our stuff into production with Docker. Biggest thing that I'm going to be concerned about here is kind of how do we take an R product that somebody has written and turn it into a container. But to understand words like container, we need to first of all talk about Docker. Okay, so we're going to make sure we understand what Docker is. So Docker is a solution where lots of the parts keep changing their name, but essentially it's like a stripped down, super light virtual machine. We put in lines of code into something called a Docker file, which we'll see later. And that provides all the instructions to build a small environment that can do everything we need it to do for our applications and processes. So this is really great for bundling up all the dependencies for your applications. So this could be websites through to data science products through to even ETL. So I've used this quite a bit for taking something that uses lots of different command line utilities like the AWS S3 command line and the Azure CLI, and be able to put them together to talk to each other and have it work in a process that is off my machine but very easily put on different environments. So it's effectively a very light virtual machine, which means that we can start off with a number of different operating systems. So you can run Windows containers. I tend to work in the Linux container space just because I find Linux an easier server product to get working. So I said everything comes from a Docker file. A Docker file starts with with a container that already exists. So in this case, we're working with the tidyverse. The tidyverse being a series of R packages that are particularly good for data manipulation and wrangling. So that container, that tidyverse container, is going to have everything it needs in order to be able to run R and these tidyverse packages. So that takes care of a whole load of configuration work that I don't need to worry about. Then it's good practice to have somebody to blame when things go wrong, so we have a maintainer. And then we can have a series of run statements that basically get things that are necessary to work. So in here, in this first section, I'm basically going in and getting SSL, curl, and XML2 and Git for being able to do a bunch of different tasks. And we basically build up these statements and layers, and then once we have this, we can go through a build process. And that build process will basically create a clean snapshot with only these steps taken. And that makes it really lightweight and easy to distribute versus a virtual machine. And because it's basically snapshotted in what's effectively a live running state. Instead of having to turn on a virtual machine and go through the boot cycle, a Docker container, when you turn it on, turns on in a second. So that has tremendous advantages for us, because if something goes wrong and our Docker container dies, then we can turn on a new one with very, very little downtime. And particularly in the R world, where we're not infrastructure people by default, anything that we can do that makes infrastructure easier by scripting it, and anything that makes it more durable without us having to do lots of stuff, is really valuable. So once you've written a Docker file, and that was a very complex example to show you the kind of level of specificity that you can get through. Once you've built your Docker image, you'll then publish it on Docker Hub. So you can do this either two ways. You can either publish, you can either build the container on your machine and publish it, or you can have a Git repository with just the Docker file in and have an automated build process on the Docker Hub. So that's a great way of making containers for people to use in a variety of scenarios. So here we're just showing some R packages. So there's RStudio that we can use. There's stuff that's great for geospatial, holding Shiny, and so these are our base images. If you want to have your own private containers, because of course you're not going to put your magic whizzy machine learning algorithm out in the cloud for somebody to download from this public repository, you can make private repositories. So those are called usually private registries. And you can get one on Azure and Google, and you can have one locally. So Docker Hub is an easy place to publish. It will do all the build stuff for you, but it's not your only option, particularly if you do not want content publicly available. You can have some private repos, but then your private repos are in with everybody else's, and that can be a security risk that you just don't want. So another common thing that people ask for, particularly when building applications, is how do we have multiple Docker containers that talk to each other? So when we do that, we have something called Docker Compose. Docker Compose is based on YAML, which is yet another markup language, and it's basically just a set of instructions of configuration about how multiple things would talk to each other. So here I'm showing the WordPress example. WordPress has an application and a database. When we spin these up, we want to spin the database up, and the WordPress have the unique password that will enable these two things to talk to each other. So this is how we're able to hook these up together. And the same will go for our applications which have multiple things. So you could have a logging database and a Shiny front end and a machine learning prediction API container. So you might have 3 separate ones, and you'll use Docker Compose to spin up all of those things together. We're not going to take it that complicated today, but I just wanted you to know what your options are in terms of linked dependencies. Then, in terms of deployment, when we deploy a Docker container, we can either run it on our machine. So we can just do from the command line Docker run and have something work. We can put a Docker container to run elsewhere in the cloud. But usually, particularly in a web scenario, a lot of people want multiple Docker containers that do the same thing. All running together. So if one container breaks, it's okay. There's lots of others to do it. So we use can use a system called Kubernetes to allow us to create that scaling, they call it fabric. So it's a nice way of deploying lots and lots of versions of your containers so that you can put things like load balancers and stuff in front of them. I tend not to do that very often, so I'm not going to take any questions on Kubernetes later today. I suspect Mark has a much better appreciation of that than I do. So my deployment scenarios are often just a few containers, and we'll see how that deployment path looks a little bit later on. So where do they go? As I said, we can host them locally. My favorite at the moment is Azure Container Instances because this is beautifully cheap and beautifully simple to get up and running. But we can also run our Docker containers in Google Cloud, DigitalOcean. You can run them on Azure Batch. There's an Azure Container Services. And basically the whole world's gone Docker mad. So we can put Docker containers pretty much anywhere we want. So let's do first demos. So we're going to go into the Azure portal, and we're going to have a look, hopefully, at the cloud command line. So the cloud command line basically allows me to copy and paste from my PowerPoint instead of doing lots of clicks and potentially missing a step. Okay. So this little button up here is our cloud shell, and we can get that working. The first time you set it up, it'll ask you to create storage accounts and things. And hopefully it'll work soon. There is a risk that my Wi-Fi is going to just completely break. It's been a bit slow for a few hours. So if that's the case and everything does break, we have a backup video of when I delivered this talk fairly recently, which you'll be able to kind of fail over to. So the CLI starts with as, and it gives us a number of options. So we have part of this CLI gives us capabilities across most Azure services. So this is really good, again, from somebody who writes R code, doesn't have to know a lot about the interfaces or how to deploy things. They can work with this command line both in the portal and on their machine. So we can see the various options in here, including the container. So that is the Azure Container Instances. This is a quick, low infrastructure way of turning on a container. So we need a space for our containers to generate into. And when we do this, we need to give a bunch of information. And you can see there are tons of things that we can be configuring. Things that are actually required: resource group. So this is basically a nice holding environment for all of our stuff. We can tell it how much CPU and memory and things are needed. DNS labels come in pretty handy because then they can, basically you don't refer to containers with IPs if you can avoid it. We can specify all sorts of things. The port mapping comes in really handy. So if you've used R before and you've tried getting an RStudio web instance going, for instance, that by default sits on port 8787, and that can really freak people out when you try to tell them navigating to a port. So what we can do here is we can say the container is going to expose RStudio on port 8787, but we want people to just be able to navigate to port 80 and just have it appear under that. So that makes URLs and things a lot easier for people. We're able to talk to Azure File Storage, unlimited file share, very, very useful. We can grab contents of containers from GitHub repos, which can help make things dynamic and always be using your latest code. We're able to go to a specific registry. So by default, it goes to Docker Hub, but if we had our own private one, we'd be able to do that. We can set up logging. And perhaps most importantly in all of this help file is the fact that they took the time for us to get examples. So these examples are really handy because you can find one that kind of does what you need and then copy and paste it and hack it until it works. So I'm going to create a group first, and this is going to allow me to make specific containers. So this has provisioned in North Europe and has the name R Docker Demos. So that's just a holding area. Oh, and in the background you might hear one of my dogs snoring lightly. So we can see we now have our Docker demos. And it tells us that we have no containers deployed to it yet. So that's the next thing we're going to want to do. And in fact, I already want to get my code live. I'm already feeling a bit sad because all I've done is talk about infrastructure and not talked enough about R yet. So the things that we're going to kind of be looking at today and the kind of things that you're going to want to ship. One thing is an RStudio environment. So in particularly a regulated environment, a regulated company, R can be quite a risky proposition. It's an open source executable that provides absolutely no warranty. Then you're downloading people could be downloading almost 13,000 pieces of open source functionality from the central R archive, and then they could be going and installing stuff from GitHub and other places as well. So that's a huge amount of code that could be coming in, impact potential security concerns, and also impacting results. Because there might be 7,000 people making changes to all of these pieces of code, and people might have one version in dev and one version in live. So a really good thing to do is to use Docker containers to basically build authorized environments with pre-agreed R versions, packages, and capabilities installed. And the great thing about the Docker containers is you can have it backed up onto the Azure file storage. So if a container goes down, you can just turn it back on and have your live environment again with all the files. Or you can be working with fresh builds every day. That makes it great for being able to quickly test things and to spin up clean environments. We might just want to put R code in, so we might have like an ETL script in R that we want to run on a regular basis. So we want to see how we can ship something that has all the dependencies needed to run an R container. Shiny is our wonderful effectively our web application platform, and we often want to be able to ship those into the cloud, particularly because we want to put load balancers and things around that, authentication systems and various things. Our markdown files are how we can interleave text and code, and they can output to everything from a website to PDFs to PowerPoint documents. So these are usually things that we're going to want to either enable a scale-out production of. So we could be looking at doing a monthly report per customer. We've got 30,000 customers. You could basically spin up 30,000 containers which do the action for each of the customers and dump the file. It's also really useful, again, if you work in a regulated scenario, because all the dependencies to run that R markdown file end up in the container. This allows us to guarantee to basically hand over a file to the regulator that is everything needed to get the same results that we got when we built the model. So that's really useful. And then the other area which we often want to ship is our APIs. So these are ways that people can talk to our code and talk to our models. So we will usually put these available with a model that we've built so that people can send our models and data and get a prediction back. And we'll see how we can also use that for other functionality, like you could be doing quick sentiment analysis, or you could be doing some geospatial bits and pieces, which your JavaScript or your C# or something might not be quite the right fit for. So let's have a look. So with our R containers, we've got Rocker, R for Docker. So we can have containers for R that contain lots of different versions. Having lots of different versions means that we can then start building a variety of test suites for our code. You can do stuff in the tidyverse. There's things around machine learning, particularly that bake in R and Python and some GPU capability, and RStudio. So we're going to create our first container. So this first container is going to run in our Docker demos that we created earlier. Let me see if I can move this font a bit. That's the largest it'll go. Okay. So we're going to create a container called Rocker. It's going to use an image that's available on Docker Hub called Docker Intro R. We're going to give it a policy about what should happen when something goes wrong, or if something goes wrong. Telling it where to run and giving it a DNS label. So that DNS label is going to help us be able to communicate with our container once it's created. So the first time that a container gets created is often a little bit slow. And that's because right now, Azure doesn't know what that file looks like, doesn't know what that container looks like. So it has to go away and grab the contents of that file. So that's going to take a little bit, and we will hopefully, whilst that's finishing up, have a chance to go in here and see what our container looks like. Okay, so this is a container that I use for training because people's machines are horrible, horrible things. And it's a terrible waste of time in the morning to spend 45 minutes trying to get people's machines working. So I say here it has a description, it's got a user's CSV file, so it has a bunch of users, sample files, and people can make their own. So we can see what's contained in this container. So we're using our tidyverse base. We're then cloning in this Git repository. We're putting a sample file into this skeleton directory. That basically means every user that gets created starts off with a template directory taken from this skeleton. So I'm making sure that whenever anybody boots up logs into RStudio, they're going to get some standard files. We install stuff, we generate our users, we can include our ODBC installations, and we can make sure that the file, all the package dependencies are installed. And this builds from GitHub. So I don't build this on my machine. I do a git commit, and then Docker Hub realizes, and it goes through and checks that everything builds. Using Docker Hub to build your containers is great because it's an extra way of verifying that your stuff doesn't break, because it doesn't just work on your machine, but you have to wait a while for Docker Hub to get around to it because lots of people have the same idea. So in here we have a description file, which is our way of saying what we need to, what our packages we need for a given process. So we have these. And we have things like installation scripts for ODBC connectors. So this is a Linux container. That's why it's .sh. But you might also have steps like this that are PowerShell, for instance. Okay, so let's see if this has finished. Looks like it has. Let's verify. So this is a statement just for querying our capability. Okay, so this says Rockademo has succeeded. So now, hopefully, if we go here to Rockademo 8787, because I left the port as is, then we should get a RStudio instance. So things that I didn't do on here was give RStudio multiple CPUs or even much in the way of RAM. So this runs quite slowly. As a result, you should be thinking when provisioning your capability, your thing in production, what is needed to make this work? Okay. So here's it remembers my login. And once this is finished, I have an RStudio instance. So you don't even need to script your own. You could just put in here, instead of lock data docker intro R or your own custom one, that could just be rocker.org/rocker. So you can have a kind of just a vanilla container, or you can make your own pretty easily. So this is super useful for just being able to have throwaway environments for developing things in, or being able to guarantee what starts off in an environment. Okay. And I'll delete my stuff at the end of this, so you should be able to take all these different lines and give them a go. Once you've created the container, once you've created your Azure command line setup. But I would generally recommend changing the names anyway, just in case a few of you do it at the same time. So that's how we can get generic R containers that do things. It's worth thinking about how we manage them. So in R, we have some packages that will be providing the baseline for a number of our packages that we're going to see that help us containerize stuff. Okay. So Harbor is by Winston Chang. Winston Chang is a very accomplished person in the R community, and the Harbor package is pretty well used. Bhaskar's Docker container, Docker package sits over the Python API for Docker, which means that we're basically able to leverage all the Python community's efforts in this area as well. And then Richard Fitzjohn has built one called Stevedore, which is much lighter than the other two in terms of getting, in terms of performance. So there's no clear winner yet. Usually with R, we'll have a bunch of contending packages until kind of one sits as the winner. So we will have to see how that goes. But this enables us to, all of these allow us to be able to talk and work with Docker in R. So this can be really useful because you don't necessarily, as an R user, want to go to the command line all the time. So I have no containers at the moment. So I'm going to get a container to be able to use it. And this is going to go to the Docker registry and get this container for me. And Docker failed. That does not bode well for me. That's the simple one. So what we're going to do is we're going to open up the command line and see if it works there. Docker runs best when you run as administrator. So I say this almost every Docker presentation I do. Docker on Windows kind of sucks. It breaks in cruel and unusual ways almost every time that I go to use it. Once you've built a Docker container, the container itself is super stable. You can host it anywhere. Our biggest problems with Docker are at the local, basically, development phase rather than the production phase. So this is working. It's pulling the latest copy of the container, hopefully, and we'll start downloading it for use. Okay, so it looks like it's just my internet being slow. I can work with that one. Okay, so hopefully my internet will speed up and we'll get that shortly. Okay. So the next thing that we want to be able to do is not just a whole environment, but to be able to take some R code that we've written and put it into production. So that could be an ETL script, it could be an API interaction, it could be a scheduled report of some sort. So the container it package available on R, on GitHub at the moment, is part of the Open Reproducible Research initiative. I'm watching everything kind of hang. Okay, so with container it, hopefully we'll be able to do this. We can take some R code that we've written. So we'll see it in a bit more depth later, but here is an R script that leverages Plumber. There's some stuff coming for being able to build and test APIs that use Plumber in RStudio. Hopefully they'll be out in the next few months. If you want to give it a go, you can go and get the RStudio daily builds, but do remember that you're basically using development iterations. So I just have some R code in here. And it has very few dependencies, but has this library Plumber piece. Okay. So this is going to evaluate our R file and work out what it needs to be able to create a fully self-contained Docker container. Okay. So it's currently creating an R session. And it's Herod. It was doing so well. Try getting my Ubuntu version going, but it's still doing stuff. So one of the problem here that I've encountered is, again, that on Windows capability. So when there's some transformations in here from what it needed to do to the stuff it was going to build, it hasn't liked the fact that we use backslashes in our file paths. So there is an issue that you can come along and upvote to hopefully get this fixed. Okay. So then if we want to put a Shiny application live and load balance it and things that you can really scale out a Shiny application, we can use a package called Rise from a great guy called Cole Brokamp. And we just have the Shiny Dockerize function that will let us work with an app and turn it into a container. So I'm just going to come into my Shiny app area. This is just a basic Shiny container, Shiny application. So we have some requirements, like it needs Shiny to run, and it's going to do some stuff on the back end, and it's going to present it on the front end. So now that I'm in the directory, the Shiny app directory, I can just run Rise Shiny Dockerize. And this is going to build the container and then make it available by default called Shiny app for me to run, or with that image I can now publish it up onto my own preferred registry. So it starts off with the default container that he's built for it, and is going to layer up what's needed to be able to have everything required for our Shiny app to run. Whilst that's running, got lots of C++ installs running on my Ubuntu container at the moment. Okay, so this is working. And we're going to, once this is finished building, I'm going to run this image locally. So in our command prompt, this a little bit bigger. We're going to do docker -h to get our command line locally. And we can see that we have various commands. And we've got docker ps to run containers, to list any containers that are currently running. Okay. So this built a container from our attempt to do stuff. So now we should be able to visit this container on port 3838 on our local host. So we can see if that's available. And I think my machine just wants to be mean to me today. My bad. The URL is 172.17.02. So Docker creates its own IP. If I'd followed my container stuff, probably would have had that. Okay. So 172.17.02. I have on Windows, again, because these things can go a bit weird. This is saved on the notes, and you can get these on itsalocke.com talks. And this helps if you get that you can't talk to your 172 containers. So you can find the IP for a container using this code. And if you're still not getting containers working, then you can use this firewall route to fix things. So let's just make sure that stuff is in the right location. It gives things nice and whimsical names, static Hamilton. Okay, so that container hasn't run. This error. Genuinely, this all worked like 5 minutes ago, this one. Well, not 5 minutes ago, but just before my session started. Okay. Everything is now just slowing down far too much. Again, in the itsalocke.com talks thing where you can get the file, you can also see a prior video of me delivering this session. So I'm going to give that a little bit of time, and hopefully that will finish building that application. But in the interim, let's talk about our Markdown products. So our Markdown products need to be shipped using a package called, well, they don't need to, but a great package for shipping them is called liftr. So we have two stages. One, lift, takes an RMD file and says, these are the things that I need to build a Docker file, and that's the output, is basically the set of instructions. And then render Docker builds the container, runs the R Markdown file, and outputs the HTML somewhere. So when we work with R Markdown, we add some extra stuff at the top in order to be able to guarantee the dependencies. Yeah, my web stuff has just gone completely down. So we have our normal R Markdown, and then we have our liftr syntax. So this basically kind of mimics the bits and pieces that we had inside our Docker file. So we've got the from, who, we're able to include some snippets of extra content for our Docker file. So this would be useful if we had some stuff that is kind of boilerplate to our organization. Could be security, could be customization. But here I'm just adding a environment variable of a user. This one is important because Docker with Windows doesn't contain this $user environment variable, and liftr can have a problem with it. Yeah, the lesson is basically work on Linux if you can for your Docker stuff. So once we have this, we can do lift and we lift our RMD file. Let me just set the right path. Okay, so that works quite quickly because all it's doing is making a Docker file. So in here we've got the all the bits we set up at the beginning, and it has stuff like here for installing packages that we'd demanded, which is this CRAN NYC flight thing. So now that we have a Docker container, it's very easy to, a Docker file, it's very easy to then go through the build process and then the push of the image so that people can create new version, can basically run this document on demand in future without having anything else but Docker installed. So this is just a note that the Docker build thing might not work if you don't have that set up. So hopefully it's not going to, I might get issues because it tried building because of my Wi-Fi issues at the moment. But this has listed the various repositories, and now if I go to Docker image, which is where all the built things live, I'm going to do -H to get the list of available options to us. So we have ls to be able to see which Docker images we've created. Then we can see that we've got our Docker containers that we've been creating here, images that we can then go and reuse. And if you look at these file sizes, that's everything it needs to be able to run our, which is just tremendously lightweight compared to a virtual machine needed to be able to run these things. So there's definitely, whilst Docker on Windows can be painful, it's much, much easier to do rapid deployments and host things in the cloud. Okay. So in terms of APIs, we've got two options. Plumber allows us to put some extra metadata above an R function to turn it into an API. An OpenCPU doesn't need that, but can operate over a whole package of capability. Plumber is a bit more, it gives people more control whilst building documentation. OpenCPU has better integration with things like JavaScript because there's an OpenCPU JavaScript library that enables you to immediately talk to basically any OpenCPU hosted bits and pieces. So we're going to do this. We're going to create an OpenCPU container, and because it's not on my machine, hopefully it'll work. So we've got the OpenCPU container. and we're going to call it Open CPU Demo, and we're going to give it 2 CPUs and 3.5 gig of memory. So this is currently creating. I should have just grabbed the URL from here. So the Plumber package has, and the OpenCPU package have just some really great documentation. And again, apologies for the lag on things. So again, all through this, there's URLs and useful resources at the bottom intended for you to go away and be able to research about these things more. So the OpenCPU website has some really good information. It tells us about how we can run applications, build local apps and things for us to use. It gives you lots of great information, including about the JavaScript library, so that you can communicate with your R models and general R functionality just through adding a single call to your web application. Okay, so that's created. Let's give this a go. Hopefully this will be fairly quick and load up quickly. So Plumber has lots of documentation as well. So that's loading up. Plumber also has the benefit that it generates Swagger. It generates a Swagger endpoint, so that anything you have like C# where you can consume a Swagger document to rapidly scaffold out classes and things, you're able to utilize those. So if you end up using APIs, there is a lot to read about, but thankfully the R community makes it quite nice and engaging. Okay. So it gives us an API explorer by default that we can use. So we have a sandbox area. We have end up with some links to the documentation, and we're able to do stuff. So this is really useful for being able to practice. Okay. So container it for generic capabilities, Lifter for being able to work with our Markdown documents, and most importantly, not have to write a Docker file, but be able to put the metadata straight up into the at the top. Rise for Dockerizing Shiny applications, OpenCPU, and Plumber for APIs. And of course, like the Rocker containers are our base, are containers that allow us to do things from host our studio to, and they get used in most of these other packages. So that's it. Sorry some of the demos didn't work. I will get them working and post videos at some point, if only just to go, yes, they work, finally. Hopefully I've inspired you to go play and given you the warning that you will encounter some problems on Windows machines. Be strong, you can do it. Okay, so it's definitely worthwhile from a reproducibility, regulatory security perspective, and being able to ship code pretty quickly and in a way IT people will understand. So this is up on itsalocke.com/talks. I'll also give the code to Mark so that Mark can make it available on the hybrid VC site if that's possible. But yeah, get it, have a look, play, learn. Thank you all very much. I apologize for keeping you a little bit late. Go and enjoy the rest of your evening and time. Thank you all very much. And I am around for questions if you want to ask some of those. Thank you. Bye.
Hi Steph, thank you very much for doing that. What we didn't say to everyone was that you only got back from India yesterday, so appreciate you being able to do this. I'm sure you're a bit jet lagged. Maybe your computer's jet lagged as well, which is why it was running a bit slow.
It's running very, very slow.
Never mind, that was good. I've got some questions for you, two of which I think are related. So the first one is really about the number of different images out there. How do you decide upon which is the right image that you need or want to use for your R stuff? And the second related question is that you seem to have an encyclopedic knowledge of R-based images. Is there a good source to go and find out what to use, i.e. some books?
No, there's not really some books yet about this topic. There are some really good blog posts out there which describe some of these things from an R perspective. The kind of canonical container images that we use in the R world are mostly those ones that are from the Rocker organization. So that makes life a lot easier because you can, hopefully, if my stuff works, we can go to Rocker Tidyverse, and it's basically anything that is in that Rocker organization.
Okay, cool.
That's what we need.
Yeah. So just be careful what images you use, basically.
Yes.
Okay.
You can also entirely build your own from scratch, but the Rocker ones are maintained by Dirk Edelbuttel and Jeroen Ooms, who are like two of the key infrastructure people holding up R. So like Dirk writes RCPP, which is about 15% of all R packages depend on, and Jeroen manages the Windows builds now for CRAN versions and things.
Okay, cool.
So very robust stuff.
Excellent. Next question. So you're using DNS labels and assigning them to the containers. Do they only work internally or are they visible externally? to the Azure service?
Those DNS labels are externally available.
Oh, right, okay.
So
yeah. Sorry, I was going to. Sorry, I was going to go and say, is there any security implications of that?
Yes, because right now this is publicly available on the Azure container instances. If you only wanted it consumable, like doing things within your Azure sort of processing environment, you wouldn't give it a DNS.
Yeah.
It's not really intended, they don't like you using IPs on those Docker containers though in Azure container instances. If you wanted to, for instance, put your Shiny application into a Docker container and have authentication as well, you can build your own custom layer, or there is a solution called shinyproxy.io, which which works quite well with a Docker environment to provide that scale out with authentication piece.
Okay. Okay, cool. I don't know if I was imagining this, but I noticed, or it looked like in your Docker file, you were basically trying to concatenate all your layers to one single layer. If I'm not mistaken there, that leads on to the question, yeah, so is there ever a time that you do decide to use multiple layers for reusability, or in this specific instance of our services, does it just make sense just to create the single layer?
Good question. I mostly concatenate them for making the download smaller. It's rare that I need to reuse so for people who are not familiar with the Docker layers bit, Docker will take each command line in the Docker file and basically say, okay, we're going to build from our previous stuff and do this extra thing to it. So it kind of builds up in layers. And of course, the more layers you have, the more things it has to download and kind of integrate together. So the kind of best practice for making a very small container is to concatenate a lot of your activities into one big long command line statement. But if you're building a lot of related containers, then you want discrete lines so that you can reuse a lot of the stuff that you've built earlier. I would mostly just want a smaller container for most of my things.
Okay, cool. Right, what we have next. Yeah, so I noticed you're using in fact I'm sure you mentioned it, the Azure CLI to interface with the Azure Container Service. Are there any considerations to using or installing this on other operating systems such as Mac OS and Linux?
The Azure CLI is cross-platform, so should work on everything. Should.
Yeah, I don't know if I'm mistaken in what I've seen on the documents for that, but it looked to me like it was suggesting on Windows you need to install it under the Windows subsystem for Linux. Am I mistaken in that? That's wrong, isn't it? That's not right.
It doesn't feel right.
No. Yeah. I must have misread something there.
It might be that the beta versions and things are like if you want the latest build.
Yeah, maybe what it. Yeah.
GitHub or something.
Yeah, maybe it was suggesting that you could use the Linux deployment in there potentially. So you could, even if you were using Windows, maybe you can use the Linux style CLI within the subsystem. Who knows? Anyway, let's move on. So I think I also noticed that you were using the latest tag a lot in your Docker file. Obviously, that's generally regarded as not the best practice. With regards your R images, is that something that you want? I mean, is having the very latest image a good thing? Would it potentially cause knock-on effects to other things?
So the one thing is that the tagging capability, the latest is only good from the last time you built your image.
Yeah.
So if I inherit our studio container at a given point in time, and then I add all my other stuff like my ODBC containers and then the ODBC drivers, and then build that image and push that image, it's at a fixed point in time. But yes, from a good practice perspective, it is a good idea to tag things. So do I still have the Rocket thing up? So the Rocket organization makes it easier to kind of, it has tags that are very useful for fixing at specific versions. But in my intro R1, of course, I regularly want to build it to make sure it works with all the latest stuff.
Yeah.
So that's why that one is always fixed at latest. Because
Okay.
I want as much up-to-date stuff as possible to train people on.
Okay. All right, that makes sense. Again, this may be down to my stupidity, but my personal experience of the Azure Container Service, and I've only played around with it a little bit, is I found it a little clunky and difficult to get started on. Is that a false perception? And if not, is this story getting better?
The container service where they put a K in it, in the acronym, or the Azure Container Instances.
I believe it was the latter.
So I really like the container instances. I found them very easy to get started with. Let me just close
So you're
down
basically
now.
saying it's down to my stupidity then?
No, I'm saying it could depend on when you learned how to do it.
Yeah.
So for me, it was like, I can add this. So the container group bit adds a bit of complexity because you're like, why am I doing this thing? But it's basically giving yourself a runtime that says, hey, I know how to do Docker stuff for you.
Okay.
So if I go into the contain, so I did it first of all, most often through the GUI.
Righto. Yeah, I think when I tried it, I initially used the GUI. I mean, I think it was back earlier in the year when I was playing around. But then I am getting on in my year, so I'm getting a bit dizzy and senile, so probably was me.
And it probably is a bit more difficult if you're using a private registry as well.
Yeah, yeah.
So I'm just using here this stuff that I made earlier. Hopefully that's just checking everything, that's all good. So that was just giving it a name to be able to manage it, a container instance, whether I wanted it publicly available or private. Here is the default stuff it loads up with. Do I want to give it a public IP, a DNS label, add stuff. So people generally, if it's just a small thing, can just click OK here.
Yeah.
And click Go after this once they've read the summary. So I found that quite easy to get on with because my requirements were maybe fairly simple in that I already had a container that I built somewhere else and I didn't have to do any OAuth or crazy things to get it.
Okay.
And I didn't need a like 60 gigabyte RAM type of container.
Yeah. All right,
You
cool.
should shard it.
Rightio. So next question, is there any anything R related within the container that would ever need physical persistence to disk? Which obviously is something that containers struggle with.
If you were doing logging, then you can either log to disk to a file. You can set it up to talk to application insights, or it can talk to a database or something. So if you were just doing file logging and you wanted those files outside of the container, then you'd want some sort of persistence. Being able to back it onto as your file storage is a great way to do that. And the important thing to do is to basically make the file name dependent on your Docker container's name and the time it started, maybe. Yeah. So that multiple containers aren't trying to write to the same file, because that way lies pain.
Okay, cool. Right. Given that sorry, let me just digest this question. Okay, given that it's getting far more easier to perform data science with tools like Docker and Jupyter Notebooks, do you foresee self-service data science as being something that is gaining traction? And given that the end user generally has a very poor understanding of data science, is it dangerous for them to do so, arriving at false or poor algorithms?
So I think I was calling it defensive data science programming the other day to a developer. You can very easily get going in much the same way that it's fairly easy to get something quite quickly with C# without knowing a lot. But there ends up a lot of difference between the quality of the conclusion, or in the C# cases, the application, between somebody just beginning and somebody who's put into place or knew enough of the kind of defensive tricks to end up at a much stronger application. It's things like when you're a beginner, you don't necessarily know which type of scaling of variables is best, or how to detect bias in your data sets. These are all things that don't necessarily change the fact that you're going to run a logistic regression or something on it. It just slightly changes the process that you go through. So we will see a lot of self-service data science being available, but the education, the kind of continued knowledge that we need to help people gain to be able to think critically and defensively about the data science process is the thing that will take us a little bit longer.
Okay, yeah, that makes sense. Excellent. Well, I've got one very general question for you now, and it's because I'm really jealous of you. So you look like you've got hundreds and hundreds of talks. You've got to share your secret. How on earth do you do it? Because it takes me months to write a single talk. Are you
when I counted last year that I'd done 23 distinct talk titles, I realized I was nuts. I probably wouldn't recommend that level of producing talks to anyone, because yeah, each talk doesn't take me months. If I know the topic really well, like super well, it might only be half a day, but most talks take me up to 3 days of actual continuous time kind of thing to make. Using R to build them, so I do most of my things in R Markdown. That greatly helps because all my code has to work for my slide deck to produce. It might not do the right thing, but it has to compile, basically. Yeah. So that adds a degree of certainty around things. That means I have to spend less time checking things. And do you know you can run SQL from R Markdown? So you could be writing your SQL-based presentations in it as well. And you can call out to the CLI, so you can call out to PowerShell to do things.
Yeah. Cool. All right, excellent. I'll have a play myself sometime. Right, well, that concludes all the questions. I really appreciate you joining me today, especially since you've had a massive trip. Hopefully I can talk you into doing it again sometime. Where are you next talking?
I am next talking in Oslo.
Ah, very cool.
So I'm doing an hour training day and then doing some talks on the Saturday.
Awesome, awesome. I must get out there sometime. All right, well, thanks again for joining me, and I hope to see you soon.
Well, thank you for having me talking today, and thank you for everybody who's made it to an hour and a half in. Thank you all very much. Have a great day. Bye.